Why does fire exist? No, seriously, stop and think about it. You've seen fire 1,000 times, campfires, candles, stoves. You strike a match, something burns, flames appear, but why? What is actually happening? Most people never ask. Fire just is. It's hot, it's bright, it destroys things. That's all you need to know, right? Wrong. When you really dig into what fire is, when you ask what's actually happening at the atomic level when something burns, you discover something so beautiful, so perfectly connected to everything else in nature, it changes how you see the entire world. Fire is not just a thing that happens. Fire is a window into how atoms behave, how energy moves, how the sun powers everything, and why you're even alive in the first place. And here's the part that's going to mess with your head. When you burn a log in your fireplace, you're not just releasing heat, you're releasing the sun. Literally, stored sunlight from years ago pouring back out all at once. Stick with me until the end, because what I'm about to show you will completely destroy how you think reality works. And I need you to comment right now. Do you think you actually understand what fire is? Because I guarantee you don't. Let's start simple. Take a piece of wood. Dead tree, sitting there doing nothing. And air, oxygen floating around, also doing nothing. The wood has been sitting there, the oxygen has been there the whole time. Nothing's happening, they're just there. But here's the thing. The atoms inside that wood, the carbon atoms, they like oxygen. They want to be together. And if they get close enough, they snap together violently, releasing massive amounts of energy. But here's the problem. If they're not close enough, they repel each other. They bounce off. So even though they want to be together, they don't know they could snap together because they can't get close enough. This is the fundamental tension that makes fire possible. Richard Feynman, one of the greatest physicists who ever lived, explained it like this. Imagine you have a ball trying to climb a hill, and at the top of that hill, there's a deep hole it could fall into, like a volcano crater. The ball is rolling along at the bottom, and it wants to fall into that hole because that's the low energy state. That's where it's stable. But to get there, it has to first climb up the hill. And if it's not moving fast enough, it just rolls back down. It never makes it over the top. It never gets to fall into that deep, stable hole. That's exactly what's happening with wood and oxygen. The carbon atoms in the wood and the oxygen atoms in the air are like that ball. They want to snap together because being together is the low energy state. But to get there, they have to first get over an energy barrier. And at normal temperatures, they're not moving fast enough. The atoms are bouncing off each other constantly, millions of collisions every second, but they're not reacting. They hit, they bounce, they separate, over and over. The wood just sits there, the oxygen just floats around. Nothing changes. This can go on for years, decades, centuries. A piece of wood can sit in the presence of oxygen for 1,000 years, and nothing happens. The atoms want to react, but they can't get over that barrier. But if you heat it up, if you give those atoms more energy, if you make them jiggle faster, then a few of them start moving fast enough to get over the top. They get close enough to snap together. And when they do, they release energy. A lot of energy. That energy makes other atoms around them jiggle faster. Those atoms get over the barrier, they snap together, they release more energy. That makes even more atoms jiggle faster. And suddenly you have a catastrophe. One reaction after another, faster and faster, all these atoms snapping together simultaneously, releasing enormous amounts of energy. That catastrophe is fire. If you're still watching, hit that subscribe button right now, because what I'm about to tell you next is going to blow your mind. Fire isn't just burning. Fire is a chain reaction that's been waiting millions of years to happen. This is the key to understanding fire. It's not that something magical happens when you light a match. It's that you're giving a few atoms enough energy to get over that barrier. And once they do, they release energy. That energy makes other atoms move faster. Those atoms get over the barrier, they release more energy. And so on. It's exponential growth. One reaction triggers 2. 2 trigger 4. 4 trigger 8. The number of reacting atoms doubles and doubles and doubles. Within a fraction of a second, you have billions of atoms all snapping together simultaneously. That's why fire explodes into existence. It's not gradual, it's sudden, because it's a chain reaction, a runaway feedback process. Once it gets started, it keeps going. The heat makes other atoms capable of reacting, which makes more heat, which makes other atoms react, and so on. It's self-sustaining. That's why fire spreads. That's why it's hard to stop. The heat from the reactions provides the energy needed to make more reactions happen. Around and around, a feedback loop. And the only way to stop it is to break the loop. Cool it down below the threshold. Remove the fuel, remove the oxygen, cut off one leg of the triangle, and the process collapses. Now here's where things get really interesting. All this snapping, all this violent atomic activity that produces a lot of jiggling. And if you put a cup of coffee over that mass of wood that's doing this, it's going to heat up. That's what the heat of the fire is. Heat is not a substance. It's not a fluid that flows. Heat is atomic motion. The faster atoms jiggle, the hotter something is. When fire releases energy, that energy goes into making atoms move faster. That's heat. That's temperature. That's what you feel when you hold your hand near a flame. Fire is not a substance. It's not a thing you can hold. Fire is a process. It's this catastrophic chain reaction where atoms are snapping together faster and faster, releasing energy, making other atoms move faster, which makes more atoms snap together. It's a cascade, and it feeds on itself. Now comment below if this is already breaking your brain, because we're just getting started. The next part is where reality really falls apart. You've been staring at fire your whole life, but you never asked the most obvious question. Where did the wood come from? And why has it been sitting there with oxygen all this time without burning? The wood came from a tree, and the substance of a tree is carbon, but where did that carbon come from? Here's what everyone gets wrong. People look at trees and think they grow out of the ground. You plant a seed in soil, the tree grows. Obviously it came from the soil, right? Wrong. The carbon that makes up the tree, almost all of it, came from the air, from carbon dioxide. The tree pulled it straight out of the atmosphere. The carbon dioxide in the air goes into the tree, and the tree changes it. It kicks out the oxygen and keeps the carbon, combining it with water to build itself. The water comes from the ground, yes, but even that came from the sky originally. It rained down. So in fact, most of a tree, almost all of the tree, came out of the air. There's a little bit from the ground, some minerals and nutrients. Those minerals are what give you the ash when you burn wood. That tiny bit of residue left behind that came from the soil. But the wood itself, the bulk of the tree, the substance that burns, that's carbon from the air. That's water from the rain. Almost nothing came from the soil. Let me prove it to you. Take a pot of soil, weigh it carefully, plant a seed, water it for years, let the tree grow big and heavy. Now dig up the tree and weigh the soil again. The soil weighs almost the same as it did before, maybe a tiny bit less because some minerals got absorbed, but the tree weighs hundreds of pounds more than it did as a seed. Where did all that mass come from? Not from the soil. The soil didn't lose hundreds of pounds, it came from the air. This experiment was actually done in the 1600s by a Dutch scientist named Jan Baptist van Helmont. He was trying to figure out where plant mass comes from. He weighed everything carefully. The soil barely changed weight. The tree gained enormous weight. He concluded, correctly, that the tree did not come from the soil, but he thought it came from the water. He was close. The water is part of it, but most of the mass is carbon, pulled directly out of carbon dioxide in the air. Now here's the question you should be asking. If carbon and oxygen stick together so tightly, releasing all that energy, how is the tree smart enough to rip them apart? How does it take carbon dioxide, where the carbon and oxygen are nicely bonded together, and undo that? Does life have some mysterious force, some magic that lets it break the rules? No, the sun is shining, and it's the sunlight that comes down and knocks the oxygen away from the carbon. The sun is doing work. Real physical work. It's pumping energy into the system. That energy gets used to push systems away from equilibrium, to create order out of disorder, to build structure. Trees are constantly doing this, sucking in carbon dioxide, tearing it apart using sunlight, building themselves out of the carbon and releasing the oxygen back in the atmosphere. That's what photosynthesis is. The tree is using sunlight to undo what fire does. Fire takes carbon and oxygen and snaps them together. Trees take carbon dioxide and rip them apart. The tree is using energy from the sun to store potential energy in its structure. And that structure, That's stored sunlight. Now comment below if you just realized where this is going, because this is the moment that should shatter your entire understanding of fire. When you take the substance of the tree and stick it in a fireplace, all that carbon and all that oxygen want to be close together again. And once you give it a little heat to get it started, it continues. It makes an awful lot of activity while it's snapping back together. And all this light and heat that's coming out, that's the light and heat of the sun that went in. It's stored sun that's coming out when you burn a log. Think about that for a second. The tree spent years, maybe decades, collecting sunlight bit by bit, photon by photon. It used that energy to pull carbon out of the air and build itself. It stored that energy in its structure. Then you cut down the tree. You let the wood dry, you stack it in your fireplace, and when you light it, all that stored sunlight comes pouring back out. The carbon that the tree worked so hard to separate from oxygen is collapsing back together. The energy that was stored is being released. Fire is just stored sunlight escaping. A log burning in your fireplace is the sun shining again. The light you see flickering in the flames, that's sunlight that fell on leaves 5 years ago, 10 years ago, 50 years ago, stored as chemical bonds, released all at once. Every photon from the fire is in a sense a recycled photon from the sun. The energy is the same. It went in as sunlight, got stored as structure, and comes back out as firelight. Now you might ask, if carbon and oxygen want to be together so badly, why doesn't wood just spontaneously catch fire? Because of that hill I mentioned earlier, the activation energy. At room temperature, the atoms aren't jiggling fast enough to get over the barrier. They're bumping into each other, but they're not reacting. The wood and oxygen are stuck in what scientists call a metastable state. They want to react, but they can't get started. It's like a boulder balanced on top of a hill. It wants to roll down. That's the lower energy state. But it's sitting in a little depression at the top. It's stable as long as nothing pushes it. But if you give it just a little nudge, it rolls down and releases a lot of energy. That's what the match does. It provides the nudge. It heats up a small region of the wood, making those atoms jiggle faster, getting them over the activation barrier. Once a few reactions start, they produce enough heat to trigger more reactions, and the fire spreads. This is why things don't just spontaneously combust. The universe is full of metastable states, systems that want to release energy but can't get started. Wood and oxygen, gasoline and air, food and oxygen in your cells, they're all waiting for a trigger. A spark, an enzyme, something to get them over that initial barrier. And once they start, they run on their own. If you're still watching, you need to subscribe right now, because what I'm about to tell you is going to connect everything together in a way that will change how you see life itself. Here's another thing that should blow your mind. The oxygen in the air, where did that come from? From trees, from plants, from photosynthesis. For billions of years, plants have been ripping carbon dioxide apart, keeping the carbon and spitting out the oxygen. All the oxygen you breathe, all the oxygen in the atmosphere, it's waste. It's a byproduct. Plants don't want it, they throw it away. The early Earth had almost no free oxygen. The atmosphere was carbon dioxide, nitrogen, water vapor. Then photosynthetic organisms evolved. They started dumping oxygen into the atmosphere as waste. For them, oxygen was poison. Many of those early organisms died out when oxygen levels rose, but some organisms evolved to use that oxygen, to burn food with it, to extract energy from it. And that oxygen is what makes fire possible. So here's the cycle. The sun shines. Plants use that sunlight to break apart carbon dioxide, building themselves out of carbon and releasing oxygen. Animals, including you, eat the plants, or eat other animals that ate plants. And you burn that carbon, combining it back with oxygen to release energy. That burning happens inside your cells. It's called respiration. It's the same process as fire, just slower and more controlled. You're taking carbon-based molecules and combining them with oxygen to release energy. The carbon dioxide you exhale is the same carbon dioxide the plants absorbed. It's a cycle. Sun to plants to animals and back. Carbon circulating, oxygen circulating, energy flowing. Fire is just that cycle, sped up and visible. When you burn wood in a fireplace, you're doing exactly what your cells do when they burn sugar. Same reaction. Carbon plus oxygen makes carbon dioxide and releases energy. The only difference is speed and control. Your cells do it slowly, carefully, capturing the energy in useful molecules. Fire does it all at once, releasing the energy as heat and light. But it's the same chemistry, the same process. You are, in a very real sense, a slow fire. Let me make this even more concrete. When you burn wood, you're converting chemical energy into heat and light. The chemical energy was stored in the bonds holding the wood's molecules together. Those bonds took energy to create. That was the sunlight the tree absorbed. Breaking the bonds and forming new bonds releases that energy. The heat you feel, that's atoms jiggling faster because energy was released. The light you see, that's atoms and molecules getting excited. Literally electrons jumping to higher energy levels and then falling back down, emitting photons. When carbon and oxygen snap together, the energy released doesn't just disappear, it goes into motion. Atoms moving faster, molecules vibrating, electrons jumping to higher orbits. And when those electrons fall back down, they emit light. That's the glow of the fire, that's the flame. Different atoms emit different colors. Sodium makes yellow, copper makes green, strontium makes red. That's why fireworks work. Different chemicals burn with different colors because they have different electron configurations. The smoke, that's tiny particles of carbon and other stuff that didn't fully react, floating up because they're hot and less dense than the surrounding air. The ash, that's the minerals, the stuff that wasn't carbon, the bits that came from the soil. That's the tiny fraction of the tree that didn't come from the air. Everything else, the carbon, the hydrogen, the oxygen, has turned into gas. Carbon dioxide and water vapor, invisible products floating away. The mass didn't disappear, it turned into gas and drifted off. So there you have it. Fire isn't just fire. Fire is stored sunlight from years ago, released in a catastrophic chain reaction. Fire is the same process your cells use to stay alive, just faster and less controlled. Fire is proof that you, the trees, the sun, and the entire atmosphere are all connected in one beautiful, perfect cycle. Now comment below and tell me, did this completely destroy how you thought fire worked? Because if it did, you're not alone. And if you made it this far, you're officially part of the Curiosity Beast family. We don't just explain things here. We destroy your reality and rebuild it better. Hit that subscribe button, because tomorrow, we're asking an even bigger question. Thanks for watching, and I'll see you in the next one.